Can you show me how Vertica can stop fraud before any damage is done?
Of course. Let me share my screen and show you a live Vertica demo based on a real banking use case.
Fraud is evolving faster than closed fraud products can adapt, while AI is rapidly increasing the scale and sophistication of attacks. US regulators require financial institutions to continuously adapt their controls as technology and threats evolve. Banks therefore need an open, extensible analytics platform alongside their existing fraud tools so they can detect and respond to new threats those tools do not yet know about. That is where Vertica fits. This is a live demo, and every query you're about to see is running right now. Vertica simply returns the results so fast that it may look as though they were prepared in advance. I'm running our fraud demonstration now. This script builds one physical event table with 800 million banking events and runs the entire fraud investigation inside Vertica live, while also measuring exactly how fast every result comes back. Here is the first result. A monthly aggregation across the complete 800 million row history returns in just 5 milliseconds. Yes, 5 milliseconds. The SQL is written against the 800 million row base table, but Vertica's optimizer automatically uses the live aggregate projection that Vertica has been maintaining continuously as the data arrives, without the application needing to know anything about it. Now, Vertica's match function reconstructs the customer journey, and in just 18 milliseconds, discovers 18 accounts that followed the same fraud pattern. We can see this clearly in the notebook graphs. The 18 journeys appear in 4 coordinated waves, and Jordan Blake's minute-by-minute timeline shows exactly how the fraud progresses from login to profile change to a new beneficiary, small test transfers, and finally the large transfer. Then, our in-database machine learning model scores the suspicious accounts at 96 to 99% fraud probability, while conventional rules saw only 6 to 13%, and the risk gap graph makes that difference immediately visible. But we don't rely on machine learning alone. Vertica independently analyzes the relationship network through shared devices, IP addresses, and beneficiaries, and the notebook graph shows how these suspicious accounts are connected to the same fraud infrastructure. Geospatial analysis then provides another independent confirmation. These accounts show physically impossible travel at more than 3,000 kilometers per hour. Finally, the real-time decision scan identifies 6 accounts for hold and review, protecting more than $44,000 before a single large transfer takes place. Now let's run the lakehouse comparison, repeating the same analytics against the iceberg copy of the same 800 million rows. The data is identical, only the storage format changes. Vertica can query both, but for these fraud workloads, native Vertica's read-optimized store format, especially with optimized projections and the live aggregate projection, can be dramatically faster. In this run, for example, the 800 million row monthly aggregation returns in 5 milliseconds on Vertica's rows versus about 4.7 seconds on Parquet. And finally, the alerts that stop the next transfers before the money leaves the bank. Everything you just saw, end to end, shows how Vertica can turn hundreds of millions of raw banking events into an explainable, real-time fraud decision before the damage is done. This demo is also available on GitHub.
I've heard about the miracles Vertica delivers for other banks. Now I see how naturally it'll integrate as our operational store within the lakehouse.